All right, this is the continuation of the notes about the markups, and we did some of those together in class. And we also wanted to look at the discount, or another way of saying these two things are percent increase and percent decrease. So let's just recap kind of what we learned about in that very last section. We said that if you just want to find the amount that something's being marked up, like the tip on a bill or taxes that you're going to have to pay, just that amount that they're going to mark the price up. It's the markup amount over the original price equals the markup rate over 100 using the proportion method. You can also do it using the percent equation methods, but remember, you just have to make sure you convert your percent to a decimal. So we did this one. Let's look at the one after it. It says your employer gave you a 3% raise, so that's going to be the markup percentage. How much more due you make if your salary before the raise was $17 per hour. So this is our original salary. So we're going to have our raise amount over our original salary equals the markup percentage over 100. Okay, so we don't know the raise amount. That's what we're trying to figure out. How much more do we make? And we want to put that over our original salary, which was $17 per hour. And that is, we're going to get a 3% raise. So if we cross multiply, we're going to have 3 times the 17 equals 100 times X. So we'll divide by 100. So this comes out to 51 cents. So the raise will be 51 cents, which means my new salary, if they actually ask me for that as a follow-up question, would be $17.51. All right, let's look at the next one. It says Ezra bought building materials with a list price of $949.95. So that's the original price, what they got it for. The items had a market adjustment of a 5% markup to account for increased shipping costs and shortage of materials. What is the amount of the markup? So we're just wanting to know, what is that markup amount? How much is it going to go up? So markup amount over the original equals the markup percent over 100. So markup amount is what I'm looking for. The original price was $949.95. We know that the markup is 5% of that whole price. So when we cross multiply and solve for this, we get X is approximately 47.4975, which will round to the nearest hundredth, usually for dollar amounts. So that would be 47, and this 9 in the hundredths place, so nearest cent, has a 7 behind it. So that's going to bump it up to a 10, which bumps this up to a 5. So this would be $47.50 is the markup amount. So that's not the new price that they're going to actually have to buy it for. This is just how much we're marking it up. So if I do want to know the new price and I don't want to have to do that 2-step process of finding the markup amount and then adding that amount to my original price, I can use, remember this formula, this is a percent increase or markup formula. You can get your new or sales price by doing new price over original price. And that is equal to, remember, the markup percentage gets added to 100 because the sales price, if you're doing a markup, is going to be more than the original price. So it's going to be 100% of the original plus the percentage of the markup part. Okay. So we did one together. Let's do this next one. So this one actually is asking us to do it the 2-part way. And then I'm going to show you how we can also get part B using just the shortcut formula. So notice this first part, part A, says, let's just find the amount of the markup. Then we're going to find the list price. So this will be their sales price. Okay. Amy's art gallery bought a photograph an original cost of $250. Okay. So for part A, we're going to have that she bought it for $250. And she's going to mark the price up 40%. So this is her original price, the markup percentage. And then, because we're only looking for the amount of markup, so that's going to be our X. If we cross multiply on this, we're going to get 250 times 40 over 100. And this just so happens to come out to 100. It just reduces down to that because this top is, I think it's 10,000. or is it 1,000? Let's see, 250 times 40 is, yeah, 10,000. All right, so that's our markup amount. So that's part A. Now part B, there's two ways I could do it. I could do a two-step process. So this is kind of part one way you can do it. Since you already have your markup amount, you can just add that to the original cost. And that is an easy way to do it if you've already found the markup amount. So 350 is there. But if I had been doing part B only and not doing the part A part, I would do the markup percentage using this percent increase version. So my new price, which is what we're going to sell it for, over my old price is 100% plus 40%. So 140% of the original over the original percentage, which is, again, it's wholesale, so it's 100%. So this would be X over 250 equals 140 over 100. So notice we're saying if this is the 100% that we bought it for, now we're selling it for pretty much 140%. So that 40% markup. So we're going to multiply 250 times 140, and we'll be dividing by 100. And when you solve this, this also comes out to the 350. So if I didn't have, if I hadn't done part A, I would have jumped straight into part 2 of B here. But if I already did part A, which is finding the amount of the markup, it's really easy just to say original price plus the markup amount. Okay. All right, so this is where I wanted to pick up the video. I just wanted to recap all that and make sure we got those examples. We're looking at discounts. So finding the amount of a discount given a percent discount. So discount amount over original price equals the discount rate over 100. And again, you can also do that using a percent equation. We talked about this one a little bit in class, but let's go through it again. I did this one using the percent equation just so we could see a version of that. So Patton bought a video game on sale for 40% off. The original price was $49.95. What is the amount of the discount? So when you're looking for just the discount amount, it's original price times the discount rate as a decimal. So original price was $49.95. Discount is 0.40. This is how much they're going to discount. So if I actually want to find the new price, I don't add here. I would subtract. I would say $49.95 was the old price, the original. They've marked it down $19.98. So now I would subtract those two to figure out the new lower price. Okay. So again, you can do like finding the new price in a two-step method. You're just subtracting when you do a discount. Ella bought a treadmill on sale at 40% off. The original price was $949.95. What was the amount of the discount? Notice again, I just want to know that discount amount. So put that over the original price. And the percent, they told us it was going to be marked down over 100. So I don't know my discount amount. I know the cost was $949.95. And I want to, they're taking 40% of 100. So notice, when we do these, we are not putting the plus 100 up here because we're not trying to find the new sales price. And plus we're doing a discount, so it's not a plus. We talked about that in class. It's actually a minus. So when we're doing this, we're just finding out what's 40% of that original cost, okay? So if I cross multiply here, 949.95 times 40, and then divide that by 100, I get 379.98, okay? So 379.98, that would be how much they were going to take off the price. So if we're wondering what the actual price is of the treadmill, we would have to do 949.95 minus 379.98. So that would be what they would actually pay for it if they were wanting to know the actual price that they're going to walk out and pay. We just asked how much are they going to take off. The discount amount is how much are they taking off the price. Okay, so this next proportion setup is exactly what we were just talking about. This is how to figure out the actual walking out the door new price after the discount has already been taken off. And the big change here is instead of mark out up, we did a plus percent, and the discount we're going to do a minus percent. So again, if you want to do it using proportions, that's fine. You can also use it doing the percent equation. You do your new amount or your new price is your original price times 1 minus the discount rate as a decimal. So just since in this section, I was doing some of the decimal equations too, let's look at this one. It says Albert found a sweater that had an original price of $74.99. It is on sale for 15% off. What is the sales price of the sweater? Notice sales price, not discount amount. So the new sales price is the $74.99, and then it's 1 representing in decimal form. This represents 100% minus 15% as decimals. Because remember, if you're doing the percent equation, you have to have this in decimal form. So this is the original, how much was it worth? And now they're taking the 15% off. So 1 minus 0.15. So we're going to be taking, they're only going to be paying 85% of the original price. So that comes out to $63.74 is what they're going to pay at the register. All right, so let's do one together. Colleen bought a suit that was discounted 25% from the original price of $245. What is the discounted price? So again, the new finished price after they've already taken off the discount. So I'm going to do this one using a proportion. So we're going to ask for the new price over the old equals the, since this is a discount, we're going to be doing 1 minus 25 over 100. So we don't know the new price. The original price or old price was $245. 100 minus 25% is going to be 75 over the 100. So notice when you're doing the discounted ones and you're looking for your new price, this top part is smaller than 100. When we're doing a markup and we're looking for the new sales price, you notice the top will be more than 100. So 245 times 75 divided by 100. I'm getting $183.75 is what they're going to pay for this suit. Okay. All right, just some phrasing to be aware of. When we read certain sentences and we're making a comparison based on a percentage, those are percent increases or percent decreases. And we can write those using the 100 plus or the 100 minus percentage, just depending on if we're going up or down. So for example, Will is 20% taller than Camille. So that's a percent increase since we're saying Will is taller than Camille by a percentage. And if we want to write that in terms of, is it 100 plus or 100 minus, this would be 100 plus 20. So Will's height is 120% of Camille's height. Okay, that's a different way of saying it. Yogi weighs 34% less than Teddy. So this is going to be a decrease. Yogi is going to be 100 minus 34, the percentage of Teddy's weight. So Yogi is 66% of Teddy's weight. Our net pay was 35% less than the gross pay. So the net pay, this will again be a decrease since it's less, is 100 minus 35, or we would say 65%. So my net pay is 65% of my gross pay. The tax and tip of a meal add 25% to the price of the meal. So we're adding something to our base. So that's going to be an increase by a certain percentage. So the total bill would be 100 plus 25 or 125% of our menu price. Okay. Let's do a couple more variations of these. And I think we have 5, 6, 7 examples left. So we're just going to go through them. So this is just mixed practice. The local car dealership bought Terry's car for $8,500. It did some body work, repainted the car, and then marked the price up by 35%. So this was the old price. We want the listing price. What are they going to sell it for? So we are going new and old. That means we want to use the 100 plus the markup percentage because we're going to find the new price. Or if you want to just use 35%, you have to remember the answer you solve for would not be the final price. It would be the markup amount. And then you would have to add that to 8,500. So again, both ways are valid. I just want to choose to do the one-step method. So my new price, I don't know. My sales price, I know my what I bought it for, 8,500. The markup would be 135 over 100 because we're marking up. So 100 plus the 35. So we're going to multiply 8,500 times 135 and divide that by the 100 that would be next to the X. And when I do this, I actually think I got a nice even number here. So it's 11,475. So that's what they're going to try to sell the car for after they did some of the work and fixed it up. Okay, Melissa bought a patio set on sale for $725. So this is on sale. So this is the new price. The original price was 12,000, or not 12,000, 1,299. So this was the old price. To the nearest tenth of a percent, what was the rate of a discount? So we're looking for the percentage this time. Okay. Well, when you have the new and old, you already can figure out what the discount amount was. A discount amount, when you know both prices, is the original price minus the new sales price. Okay. So 1,299 minus 725, that will tell us how much it was discounted by. And this comes out to $574. Okay. Now we can either do a percent equation or the proportions to solve for what was the rate of discount. Okay, so what was that percentage? So we can take our discount amount, because we want to know what percentage is that out of the old price. And that's going to be our percent out of 100. So we needed this discount amount to go on the top there so we could solve for our percentage. So 574 out of 1299 equals what out of 100? So what was the discounted percentage essentially? So 574 times the 100 divided by 1299. And we're going to round to the nearest tenth of a percent, they said. So this is 44.18. So that one's going to bump up to a 2. So this would be 44.2% is the discount rate. Okay. All right. Jasmine earns $890 a week after a 15% pay raise. That's a markup. What was her pay initially? So 100 plus 15. So we have her new pay. We're looking for her old pay. So again, anytime you're looking, you have both, new price, old price. When you have both of those, you're going to be looking at the markup or the discount where we do either plus the percentage or minus the percentage. Okay. Round our answer to the nearest dollar. Is this a percent increase, percent problem, or percent decrease? This one would be a percent increase problem since they gave her a pay raise. So the new is $890. New goes on top. Original was her original old pay. We don't know that, so that's the bottom. And then we have 115% over 100. And we're going to cross multiply here. So this is 890 times 100 divided by the 115. And let's see what we get. 890 times 100 divided by the 115. Rounded to the nearest dollar. This is going to be the 0.9. We'll round that up to a 774. So her old pay at this job was $774 a week. And after her 15% raise, now she's making that $890 a week. Gracie pays a total bill, advertised room rate and taxes of $290 for one night. So this is the new, this is what we paid. But the tax rate in New York City on a hotel is 22%. So tax rate is a markup. So it's going to be 122% of the base. What was the room rate before taxes? So we're looking for the old. So 290 over the old price. And we know that's 122 over 100 because the markup for taxes was 22%. So if we cross multiply, we get 290 times 100 divided by 122. And this one, let's see if we need to round it. So 290 times 100 divided by 122. Let's see. They didn't tell us rounding rules, so I usually go with the nearest to what we rounded here. So since they did nearest whole amount, for the actual what they gave you, I'm going to go to the whole amount here, just since there wasn't directions. That's typically a general rule in math, is if they don't give you rounding directions, and you need to round for something like money, because money usually is only either to the whole dollar or to the nearest cent. I would go with whatever format they already had the money in if they don't give you directions. So this will be a 7 will get bumped up to an 8 because of the 7 behind the decimal. So X is approximately $238 is what they would have paid before the taxes for that room. All right, and then we have Christopher invested in a startup company 5 years ago, and his investment is now worth $14,350. His investment lost 8% or 18% total over 5 years. What was Christopher's original or his old investment? Okay, so this is what it's worth now, or the new. He lost. So this is not plus 18%. This is going to be minus 18%. He is losing or having less money than he originally did. So we should expect the older investment to be larger here. So 100 minus 18 is 82 out of 100. So 14,350 times 100 divided by 82. And this comes out to a nice even number. It's 17,500. So that's what his original investment was before he lost the 18% over the 5 years. All right. So we just have this last page. Between 2000 and 2010, the percentage of households with cordless phones increased by 10.5%. So this phrasing here, increased by this percentage, that is the markup, okay, or the percent increase. But the data value is actually a percentage as well, because notice they're measuring percentages of homes that have a cordless phone. So all of our data values up to this point have been things like weight or grams or money. You can have data values that are percentages too. This percent, though, is the markup percent. This is just a data value, okay? And it is our new, because it's what we had in after the increase. So this is the new value. What percentage of households had cordless phones in 2000? So we're looking for the old. And I put a little note here. When your data is in percentage points, just drop the percent symbol for your calculations, okay? So new is going to go on top, remember, over old, which we don't know. And the markup, it would be 110.5 because we're increasing by 10.5%. So we would do 86 times 100 divided by the 110.5. And round this probably to the nearest 1/10 of a percent. They usually say that on the directions, but I'm doing that just because that's what I believe it was in Newton. I didn't put it in there as a type of the directions. So I ended up getting 77.8% because it was 7 repeating, I think. But let's triple check that. 86 times 100 divided by 110.5. Yeah, 77.8. It actually did not round up because the 2 behind it doesn't bump it up. And that would be the percent that had cordless phones in 2000. Again, looks like it's a percentage, but it's a data value because our data that we were talking about was what percentage of people had these phones. That is why I'm still keeping a percent here. Usually you do not have percent symbols on your X and Y, your new and your old, whatever you want to call these guys here. But unless the actual data we're talking about is a percentage, okay? All right, and then the last one, a home recently sold for 1.3 million, so that would be a newer value. 18% above the price, okay? So that's a markup of 118% of the base. And what was the price before the markup or the increase? So that's going to be the old, okay? Sorry, my kids keep asking me to play Minecraft. So we have, and this is million, so we're going to need the 10 to the 6. So 1.3 times 10 to the 6 is the new. We don't know the old price. We know it was a markup of 18% of the base, so 118% total for the new price. And when I cross multiply and get this, I got the following, and I'm going to carry it out to a few decimals. Kept going. And since this wasn't it was in millions already, I'm just going to go ahead and round this to the nearest whole dollar. So 1,100,000 $1,695, because the 9 would bump the 4 up. So that would have been the old value of that home before the increase. Okay, I hope this helps.